All right, so let's try this. This is number 29 out of 14.1, which says, describe the differences and similarities between these three parameterized curves. So the first one's x is t and y is t squared. Okay, so what does that do?
X is going to increase linearly while y is going to increase exponentially.
Yeah, I mean, I could even eliminate the t's, right? If x is t and y is t squared, then y is what?
X squared.
Right? So this is like x is x and y is x squared. So that's going to look like parabola. Yes? And it reaches a dot here at x comma f of x, or x comma x squared. How about? It reaches that at time when? T is?
T squared.
No. No. X is t, right? So this thing hits x at t is x. Don't overthink this.
Yeah.
Right, so this goes through 0, 0 at time 0. It goes through 1, 1 at time 1. It goes through 2, comma 4 at time
2.
2. It goes through whatever what's the next one? 3, comma 9 is the next convenient one, and it goes through that at t is 3, right? You guys all good with this? Okay, how is this like b where x is t squared and y is t to the fourth?
It looks like a parabola still.
Yeah, this seems like it still looks like a parabola, right? Because if x is t squared, then y is x squared still, right? You guys all see that? But
It goes up
He's
way
good.
faster.
He's really good.
yeah, okay. One, things happen faster, and two, can x be negative?
No.
No.
No. So this traces out the right-hand side of the parabola twice. You guys see that? It goes this way for t is smaller than 0. Then it hits the bottom at t is time 0. And then it goes, yeah, right back up the other way for t is bigger than 0. You guys see that? It hits this bottom at t is 0. It hits the same points, right? It hits 1, 1, and 2, comma 4, and 3, comma 9. But what are the times on those?
Time 1 and negative 1, time plus or minus 2, time plus or minus
Good. So it hits 1, 1 at time 1 and also negative 1, right? It hits 2, comma 4 at t is plus and minus root 2. You guys see that? It hits 3, comma 9 at t is
root 3.
plus minus root 3. Yeah, we could slap a domain restriction on this one, right? Like if we restricted our original to t is bigger than 0, and our second one to t is bigger than 0, we still wouldn't have quite the same curve. Sorry, false statement. We would have the same curve, but at different speeds. You guys see that one? Because this one's going to move linearly in the x, and this one's going to move faster than linearly in the x, right? It's going to pick up speed because it's x is t squared. You guys all see that?
So when you say the same curve, you mean like the same like?
Yeah, I mean the same curve in the xy plane, right? If I restricted this one, they'd be the same curve, but this one gets traced out twice and faster. You guys see that? Well, faster. Faster is a little bit of a lie, but. All right, how about this one? X is t cubed and y is t to the 6th.
Same kind of picture, but you pick up the negative again.
Yeah, this is the same kind of picture, right? Because here, y is 2 to the 6th, which is t cubed squared, right? So this is still y is x squared. So I still have my parabola. I do get the negatives again, but time changes again. You guys see that? The time on this one is yet different than either of these. When does it go through 0, 0?
0.
Goes through 0, 0 at t is 0. It goes through 1, 1 when t is
1.
1. It goes through minus 1, 1 when t is
Negative 1.
negative 1. Okay, those are all the same, right? But now when does it go through 2, 4?
Third root 2.
Good. At the cube root of 2. And when does it go through minus 2, 4?
Cube root negative 2.
T is the cube root of negative 2, which is negative the cube root of 2. You guys all cool with that? No, when I'm saying faster, right, I really mean faster past 1 because it's slower in the middle there. Cool? Questions, Steele? Why is it slower in the middle? See what I mean? What's x cubed look like?
A single tangent line.
This thing, right? Looks kind of like one of the parts of tangent. So this is x of t, right? Is t cubed. And over here, that x is parameterized by x of t is t, right? What's the graph of x of t is t? Yeah, that's a line. What's the slope of this line? 1. That looks like this. If I put those two together, right? You get a picture that looks like this. You guys see that? So if I'm thinking about faster, right, I'm asking when is this slope steeper than that slope? And for a while here in the beginning it is, and then it catches the same thing. And it's not quite at 1 that transition's made, but it's in there. That's cool. Maybe it is at 1. No, it's not quite at 1. Cool. Questions, Steele?